What if I told you there's an AI model out right now that can read an entire book, analyze a massive software repository, fully understand images and video, write production-grade code, and then act as an autonomous AI agent? And what if I told you it could do all of that at the exact same time? Now, you might be thinking this is a pitch for some distant, futuristic tech, but it's not.
This is literally what MiniMax is designed to do right now. And honestly, the crazy part? The AI community is kind of sleeping on this one. While everyone is endlessly debating the latest updates from the usual closed proprietary models, MiniMax just quietly dropped what might actually be the most feature-dense open-weight model of the entire year. So today we're doing a completely hype-free technical breakdown of exactly why this matters, and more importantly, what you can actually build with it.
Okay, let's dive into this. Over the exact next 8 minutes and 10 seconds, here is our roadmap. 1. The core capabilities. 2. The developer deep dive. 3. The research accelerator. 4. Reality check and limitations. And 5. The open-weight future. All right, kicking things off with Section 1, the core capabilities. Let's break down MiniMax.
So, to really get what makes this model so unique, you have to look at the current AI landscape. Most AI models out there specialize, right? You have your incredible coding models, your long document models, and your multimodal models for images and video. But getting all three in one place, that's rare. Getting all three in an open weights model, almost unheard of. MiniMax claims to master all three simultaneously. And the absolute crucial point here, the headline feature you absolutely cannot gloss over, is this number, 1 million. A 1 million token context window. To put that in perspective, most standard models tap out around 128,000, maybe 200,000 tokens. 1 million tokens literally means you could theoretically input an entire novel, a massive full code base, dozens of dense research papers, or hours of meeting transcripts, and the model keeps every single detail active inside a single conversation. Now, MiniMax guarantees 512,000 tokens, but its sparse attention architecture officially supports up to that massive 1 million mark.
But that massive context window is just one piece of the puzzle. We've actually got 3 core pillars here. The 1 million token context window, frontier coding and agent capabilities, and native multimodal understanding. Having all 3 of these incredibly powerful features combined within a single open weights model is genuinely a real game changer in today's landscape. Because it's open weight, it means developers can run it, fine-tune it, and integrate it without having to route all their sensitive, proprietary data through some third-party API.
Let's look a little closer at those agent capabilities. This data right here brilliantly illustrates the sheer coding and execution power of MiniMax. On SWE Bench Pro, which is a benchmark that measures real-world software engineering tasks, it scores 59%. On Terminal Bench, testing autonomous terminal execution, it hits 66%. And on MCP Atlas, which is for complex agent orchestration, it reaches 74.2%. Now, why do these numbers matter? Because they measure whether an AI can actually execute complex tasks inside your computer, rather than just politely explaining to you how to do them. It's not just talking, it's doing.
And then we have that third pillar, native multimodal understanding. MiniMax was built from the ground up to process text, images, and video together. This isn't bolted on as an afterthought. There are no clunky wrappers trying to force disparate systems to talk to each other. This native architecture is absolutely crucial for anyone working with visual data, complex diagrams, charts, presentation slides, or multimedia. The model just understands the relationships across all these formats natively right out of the box.
Moving right along to Section 2, the developer deep dive, let's look at some practical workflows.
Because, benchmarks are fine, but let's see how this actually plays out in the real world. Imagine you've just inherited a massive, completely undocumented codebase with tens of thousands of lines of code. Normally, just finding the bugs and understanding the architecture takes days of grueling, tedious work. Well, let's see how MiniMax handles it in 4 clear steps. Step 1, feed it everything. Because you have that 1 million token window, you just dump the entire repository into the context. API docs, error logs, config files, the whole shebang. Step 2, ask architectural questions. Let the model build a mental map of your actual code and map out all the major dependencies for you. Step 3, narrow to the problem. Feed it an error log, and ask it to trace the call chain end to end. And Step 4, use agent mode for execution. Let it autonomously run terminal commands and test patches. And this brilliantly illustrates how a 2-day debugging nightmare simply becomes a 2-hour workflow. You are not just chatting about code anymore, you are literally watching it actively work on your machine.
Next up, Section 3, the Research Accelerator, Information Workflows. Let's pivot to a second practical scenario. This workflow is perfectly designed for students, academic researchers, or really anyone dealing with massive reading lists and incredibly tight deadlines. Here is the step-by-step process for this research accelerator. Step 1. Gather your sources. Lecture notes, raw, unsummarized PDFs, textbooks. Collect it all without filtering. Step 2. Drop it all in. Load everything into a single session. You don't have to worry about the AI losing track of earlier documents because of that huge context window. Step 3. Ask synthesis questions. Now, don't just ask for basic summaries here. Ask it to identify contested claims across all those documents and cross-reference where different authors actually disagree. Finally, Step 4. Generate study tools. Have it create visual concept maps or structured outlines based on the text and diagrams it just processed. You are essentially compressing hours of tedious prep work so you can maximize your actual thinking and analysis time.
All right, time for Section 4, Reality Check and Limitations. This is the crucial disclaimer.
Look, those workflows we just talked about are undeniably powerful, but it is time to pump the brakes just a little bit. This is the part most AI creators skip over, and it's absolutely crucial for a grounded understanding of this tech. As the quote says, the benchmarks, the capability claims, they're self-reported. While these specs look incredibly impressive on paper, almost everything we currently know about the performance comes directly from MiniMax itself. The broader AI research community is still actively waiting for independent third-party evaluations of this full open-weights release. We really need to stress test this against real production workloads before we start drawing any definitive sweeping conclusions.
And beyond just the benchmarks, there is a much broader tension we have to acknowledge here. Autonomous agents require serious oversight. As models gain the true ability to take tangible actions inside a computer, we're talking terminal execution and long-horizon planning, questions around security, reliability, and proper oversight become absolutely critical. A model that can execute actions isn't just a friendly chatbot anymore, it is an active actor in your system, and that demands immense responsibility from both the developers and the companies deploying it.
Finally, Section 5, the open-weight future. Let's talk about shifting access.
Despite the very real need for careful evaluation and oversight, releases like MiniMax are actively shifting the balance of power across the entire AI landscape. Think about it. On one side, we have massive API bills, which is the very expensive reality for many organizations relying on proprietary, closed models. But on the other side, competitive local infrastructure. Open-weight models with the frontier-level capabilities of MiniMax fundamentally flip this dynamic. They give individual developers, academic researchers, and smaller companies access to incredibly powerful AI infrastructure that they can run locally on their own hardware. A researcher who previously needed massive institutional funding just to access cutting-edge tools can now experiment freely. That is a truly meaningful shift in global access to AI.
So I want to leave you with a final provocative question to think about. Which of these workflows would actually change how you work? Would that developer deep dive save you days of stressful debugging? Or would the research accelerator completely transform how you handle complex, dense information? Or maybe, you have a completely different use case you'd want to throw at a 1 million token context window. Think about how this massive capability applies to your daily tasks. If you found this explainer helpful and you want more grounded, workflow-focused technical deep dives just like this one, make sure to subscribe. We are always breaking down the latest developments to help you understand what actually matters in the real world. Thanks so much for joining me, and I will see you in the next explainer.